Hello everyone, it's Mike Levin. Thursday, October 12th, with a starry night on a rainy day, 2017, at around 8:15 a.m. On my way into the office and on a mission. I have not been proceeding nearly as fast on my work as I had hoped and intended to. At first glance, I thought I just had to select data from 3 different tabs in a Google spreadsheet, do a few data transforms, and plop it into a 4th tab, a 4th and a 5th tab, something along those lines, in order to be done my job. And I do that kind of thing in SQL all the time through my career since, like, I don't know, 1998, when I first started using SQL Server 6.0, which was, I think, the first port to the Microsoft platform. Before that, it was only on OS 2. And it was Sybase. It was a partnership between Microsoft and Sybase, one of the database vendors at the time, which had morphed and transformed into the SQL Server of today. I'm sure it's been rewritten from scratch several times by now, but yeah, I go way back with SQL. I'm sure there's people who go back far earlier, but I certainly was there before the SQL 99 standards were even in place, and I learned when something called theta joins were the norm, where you said, you know, join table A to table B, where the values in this column from table A equal the values from table B on this other column. And, you know, that's still what a lot of people think of as normal SQL, but it's been replaced by all this, you know, left and right and outer and inner for controlling your sets, and joining on column names, not where something equals something. So the syntax has changed a bit, and, you know, I think in SQL it's one of those tools. It's like HTML. It's a declarative language. You don't have to worry about implementation. Very smart processes in the background do something a lot like the compile process to figure out execution plans and optimization. So you're spared a lot of the grisly details of the kinds of requests you're making, although it could manifest as really long execution times, in which case manual optimization is called for, but I digress. I'm the kind of person who controls my own indexes. I'll design the tables around performance optimization, knowing how the application's going to be using the data. And now I'm in Pandas, in Python. It's a very different world. There are a lot of assumptions in the SQL world, and as with any tool, it's one of those things in tech. There's not a lot of fixed positions in tech that allow you to gradually ascend in your skills and achieve mastery. Languages change and come and go. Text editors and IDEs come and go and change. Even Python in its own way changes, but at a gradual enough pace and with adequate strategies, such that you're never getting the carpet pulled out from under you. You'll never go obsolete on Python. And the same is true of SQL, yet the way you interact with data in SQL is not Pythonic. Stringing together these long strings of, you know, text commands that you embed into Python, well, that's called going around the ORM, the object relational model or mapping that's built into a lot of these, you know, interact with the database tools that are out there. SQL Alchemy people are familiar with this, but, you know, it's pretty much in anything that's trying to isolate you from the SQL underneath. Well, the only reason there is SQL underneath is that, you know, you're doing something with a probably deployed database of some sort, or that you feel you need to. And so you have all this infrastructure overhead that doesn't really need to be there if all you're doing is answering questions on data. If people are querying you and you need to query or turn around and query other things, you don't necessarily need privileged access to all those tables and stuff. All you need is a feed. All you need is a way to query against it to get some of that data on your side. Then you can turn around and you can hit 4 or 5 different systems, query each of them in turn, and basically do all your operations in memory and do very SQL database-like things with neither SQL nor a database as most people think of it in the picture, just Python, limited by various factors, the most obvious of which is how much data you can manipulate in this way, because each time you do a pull, there's some data being transferred, so you don't have the advantage of being tightly coupled or local on the network. If you need to store that data, you got to cache it somewhere, maybe locally as CSV text files. So there are downsides to working with this way, but one very big upside: you will always be able to apply these techniques, and it is not keyed to the database or IT environment that you find yourself in. It just works anywhere, everywhere, all the time, and gives you a grab box of tools and capabilities that are just totally out of hand. So I oftentimes talk about my development and runtime stack as Linux, Python, Vim, and Git, although of course things like Vim aren't really in the runtime stack. But with just those 4 tools, and of course some of these tools are loaded Linux. What do I mean by that? It's generally the terminal and the command sets that's in common to most infrastructures, technology infrastructures out there. But Linux, Python, Vim, and Git is enough to get you by and to be in your back pocket in the world of tech to help you take on and tackle any problem. And I spent quite a few years mastering Vim, and it's awesome, and it is the way to code up automations. Once things have been promoted to the realm of needing automation, and it puts you in sort of a less mobile, less agile, less able to pivot at a moment's notice position because you don't want to, because you don't want to break your automations. And then when it comes time to experimenting and pushing the boundaries, you need to think through, dare not do it on the production machines, but when you're working ultra lightweight like I am, it's an option. Yet, being there in Vim with certain copy-paste limitations of the terminal, and certainly with limitations in the stupid programmer tricks you can do while the code is executing, is quite limited. For the ultimate degree in doing breakpoints and inspecting variable values and stuff, you want things like a Python-specific IDE such as PyCharm, or believe it or not, the open source version of Visual Studio. Microsoft has made tremendous strides on this front. Or you want Jupyter Notebook, which is not quite an IDE, although it has a variety of IDE features like object introspection when you hit the tab key after a dot. But it's a run, execute, print loop, REPL environment, or an interactive shell, which is almost like an IDE, but whereas an IDE, you'll set a breakpoint on where you want to stop. In a REPL, you can execute your code line by line, inspecting variables as you go on, re-execute loops of code, and write a function down here below where you're working, execute it, have the function in memory so that you can apply it to something in the script that's higher up. If you're happy with it, then you can arrange stuff which is generally written flat for best experience in Jupyter Notebook. Ooh, there's an interesting point. I'm digressing, I'm going down tangents, but for people taking the plunge into Jupyter Notebook as a way to access Python and Pandas, which I highly encourage. It's a big point of this. I'm saying Linux, Python, Vim, Git. I'm adding to that Jupyter Notebook, which goes against every fiber of my being for the type of developer and coder that I am. But it's still worth it, because when you get up to that experimental point where you have an automation running over here, but a request hits you, you go to your local machine, you do a git pull to get that same code base that's running on the server onto your local machine, because it's going to run correctly on your local machine, right? Well, yes, because Jupyter Notebook is a sufficiently common runtime environment so that you have a high degree of code portability between machines. Now, when I say this, I'm not just saying this as someone who occasionally does this. I created my own Linux distribution called Levinux. It's actually a respin. I didn't do that much work except taking a few files and arranging them and putting some custom scripts in, but that's what all Linux distros really are anyway. I'm just using convenient containers provided by the amazing Tiny Core Linux project in order to create a Linux console, a little type-in user interface, which is a full-fledged Linux machine as a virtual machine on the desktop of your Mac, your Windows machine, or another Linux desktop such as Ubuntu. And I did this so that there was a common runtime environment so that projects and tutorials that you make based on the Linux or Unix, IT infrastructure could be packaged up and distributed and just brought up on people's desktop no matter what. And it works. I've got a little bit of a following. And I did that because in the field of SEO, if you're not doing it for yourself, if you're not walking the walk, you shouldn't talk the talk. So I always have various irons in the fire. These YouTube videos are one of them, Levinux is another. But the topic of application portability is way up there on my mind because of my almost paranoia about not being allowed to be rendered obsolete, either by the happenstance developments with software providers, as happens with Microsoft forcing everyone onto .NET as they chased the Java, shift in the industry, and then subsequent fad-based movements which yank you all over the place, make you have to constantly retrain, and all this extra effort goes into just keeping yourself able to be baseline productive. You don't want to stay at that baseline of productivity and have to relearn just to keep your head above the surface. Joel Spolsky talked about this before he became a Microsoft fanboy, about how Microsoft does that specifically to keep the edge in Microsoft's advantage. And he retracted that. I think he called it duck and fire and duck. It's a strategy by which in the military you can gain ground little by little, so long as you can suppress the opposing fire. If you can't, you're locked in place. And what's worse, the enemy can be advancing on you. So it's a matter of which side has the greater number of people firing. And so software developers and operating system providers and hardware providers and people who control that full vertical stack, such as a few of those amazing companies out there do, can control a lot of details about you as a professional and lock you in. And sometimes you just don't know that's happening, and even when you do, you don't know how to escape. And even when you realize it and you want to escape, the escaping is tremendously difficult and tricky because you are now uniquely keyed to the products provided by those vendors. And they do go away, and they do shift in form so much that it's as good as going away. So Linux, Python, Vim, and Git pretty much never will. So master them, put in your 10 years, whatever, have it in your back pocket, have that as a second way you can take on and tackle any projects and challenges in any domains that come your way, because that covers a tremendous problem domain. and specialize in your whatever that you're going to make money on fast, because it's where the sexiest 6-digit salaries and jobs are. But always use those 4 tools as your go back point. And I'm adding to it now because I'm trying to become a data master, because I'm trying to reposition myself from one thing to the next. I need to be able to slice and dice and merge and concatenate and aggregate and do all this stuff and report on and visualize and tell stories out of data. That is where my future resides. I need to be able to tell people what to do, why, and back it up with such stunning, support that they go, wow, that's right. And then when they do what I say, it has to be verifiably working, tracking systems surrounding it. And so all these pieces I'm now starting to connect in my career. And one dot that I really like to connect is that true data mastery that lives in this SQL side of my brain, which is not going obsolete, I'll tell you. It's one of the best keywords you'll have in your resume. But the world does not begin and end at SQL. And I thought picking up Pandas was just going to be a one-to-one mapping between SQL and Pandas. And to some degree, it's there. And you can even use libraries that let you use SQL before you start posting that in the comments. I know about Panda SQL and all that other stuff that lets you resist what you really should be doing, which is to learn the Pythonic and the Pandesque way of doing things. Pandas has an API that plays off of Python's own API, and it's pretty awesome. It's tons of inside jokes where you can express filters where it's just the greater than symbol and some number, and that's the filter in an index where you would normally put a number, a keyword, string. You can put evaluations or operations, because the way you would do one-to-one operations between two one-dimensional, zero-dimensional, well, whatever a cell is, A equals B. You can do between compatible sets. So column of DataFrame A equals series B, or insert series B into column A of this data frame, knowing that compatible sizes and dimensions are just going to make it happen. So you can paint grid stuff in the background, in memory, in the data frames. Key revelations and insights. You're joining me on my Python journey. Let me share with you the first series of insights. Import pandas as PD. You're always going to have that at the top of your file. And then PD this, PD.this, and PD.that is the way you access things with PD.DataFrame. Capital D, capital F are in fact the most important one. So that can take a series of objects in to create a data frame, or you could do PD.load CSV to load CSV files, and you can get it from URLs out on the internet and all that. But the revelation is that these data frames are typically, not always, but typically, two-dimensional X by Y, relational database, Excel tab-like data structures. And so most of the stuff you can do with them is kind of familiar. Don't be intimidated by the word data frame. The second realization is that whole operations can apply to each other as if they were non-sequences, but they are sequences or arrays. So you can do operations like inserting a list straight down the column of a spreadsheet by saying, take this list and stick it in that column. And that's just par for the course. That's just where things start with pandas. All those things you might have wanted to do with lists, tuples, and dictionaries, but you're like, oh my God, how would I go about that? This kind of stuff should be easy. This sort of manipulation of tabular data, doing stuff with matrices, it should just be boom, 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 you know, if you know the commands and the magical incantations. And so the magical incantations for doing all that stuff, all that database SQL-like stuff, while in a more Pythonic and arguably more elegant, faster to use, more flexible environment, API, under Python, under Jupyter Notebook, under any desktop operating system you might happen to have, is from pandas import PD. Object name equals pd.dataframe open parenthesis and a list of lists, or a dictionary of column lists, or some other data structures that it takes in, or loading it out of a CSV or pulling it out of the database, is the first step. Get that data frame in memory, get ready to do stuff to it, and all that painting in the background and then updating something somewhere is what I'm doing right now. So thanks for joining me. Hope to see you again soon, and don't forget to subscribe.